Okay, so today's lesson is on solving systems of equations, and we're going to solve by graphing first. In order to solve a system of equations by graphing, you have two choices. You can use slope-intercept form and begin at the b and move the slope. Or if it's in standard form, you can try to solve for the x and y intercepts and then graph. And of course, there's always the option of a table of values. So we're trying to find the solution that's going to make both equations true. So an x and a y value that work for both equations. Okay, that is our goal. So let's look at number one. And the first one is in standard form. So standard form, it says to solve for x and y intercepts. To find the x-intercept, you cover up the y and solve for x. In this case, x would equal 0. To find the y-intercept, you cover up the x. So if you're negative 2y equals 0, y equals 0 as well. And the x and y intercepts are both 0. That does not create a line. It only gives us a point. So for this situation, we need to also create a table of values. And we only need one value because we have a point already. So I'm going to say, what if x is 1? And I'm going to plug in 1 for x. And solve this equation. Negative 2y equals negative 1. Y equals 1/2. So when x is 1, y is 1/2. And then I can put that point. If I notice I go up 1/2 over 1, so I can follow that pattern across my graph, going in both directions, and then create that line. The second equation is in slope-intercept form. If you're familiar with slope-intercept form, y equals mx plus b, you always begin at the b, which is at negative 3. It's a y-intercept. And then you move the m, which is a slope. And if it's not a fraction, we make it 1, 2 over 1. So we go up 2 over 1, up 2, and over 1. And then we create that line. Our solution is where these two lines meet, which is right here. And the coordinate of the solution is 2, 1. And then you should check mentally to make sure these work. 2 take away 2 times 1. 2 take away 2 is 0. And then 2 times 2 is 4, minus 3 is equal to 1. So that works. So now let's look at number 2. The first equation, again, is in standard form. And so for standard form, if we cover up the y, the x-intercept is equal to 4. The reason why I'm covering up is because the x-intercept, y is 0. So I'm making it 0. And if I make the x 0, then y would be 2. So on the x, we put a point at 4, and on the y, we put a point at 2, and then we're going to connect those 2 points. The second equation is 2x minus 3y equals 1. Again, if we want to find x, we cover up y, and so we get x is 1/2. And then to find y, we cover up x. Y is negative 1/3. So if we go to x is 1/2, and y is negative 1/3, and we kind of approximate that line, we can see the two graphs intersect at this point right here, which is 2, 1, the same solution as the last one, and we check. 2 plus 1 times 2 is 4. 2 times 2 is 4, minus 3 times 1 is 3. 4 minus 3 is 1. So that one works. So let's look at one more together, and then you'll try the rest on your own. So the first equation, again, is in slope-intercept form. Is in standard form. So we're going to do the x and y intercepts. So if we cover up the y, the x equals 3/2, or 1.5. And y, if we cover up the x, is equal to 3. Okay, so we go over 1.5 and up 3, and we have that line. Oops, I kind of went a little funny with my line. And then the second one is in slope-intercept form. So the y-intercept, or begin at the y-intercept, negative 9.5 is negative 4.5. And then 1/2 is a slope, so it's up 1 and over 2. So we go up 1 and over 2, and up 1 and over 2. We get something like this. And if we look for our intersection point, it looks roughly to be here, which is at 3, negative 3. And then we can check. 2 times 3 is 6, minus 3 is 3. Half of 3 is 1/2. And if we do 1/2 minus 4/2, we get negative 3. So they both work. So that's the I do for graphing. The you do is below. Now we're going to go to the next page. And we're going to do the I do for algebraically. So to solve algebraically, you can use substitution or elimination. Okay. Substitution, you solve one equation for a variable and then substitute it into the other equation, then solve. Take the answer and substitute back into the first. So we're going to do one with substitution and then elimination, write the equations in standard form, find a common coefficient for one variable on both, and then add or subtract to eliminate that variable. Take the answer and plug it back into either equation to find the other variable. And we're going to do that. So we're going to do the first one with elimination. Okay, elimination. And to do elimination, we need to look at the x and the y, make sure they're lined up, which they are, and then get either the x to be the same or the y. In this case, it's easier to make the y the same because I can multiply the top equation by 2 and get my y's to match up. So 2 times 8 is 16x, 2 times 3 is 6y, and negative 5 times 2 is negative 10. And then to eliminate, because it's 6y and plus 6y, they're both positive, I need to subtract to get rid of them. 10 minus 16 is negative 6x. The 6y's cancel. Negative 13 minus a negative 10, it gives me negative 3. Divide by the negative 6. X equals 1/2. And then I'm going to plug that back into one of the original equations. So I'm just going to go with the first one, 8 times 1/2. Plus 3y equals negative 5. 4 plus 3y equals negative 5. Minus the 4, 3y equals negative 9. Divide by the 3, y equals negative 3. So I got the y value and I have the x value. When you write your answer, because this is the system of equations, like the first page, it's where they meet on the graph. So the answer is a coordinate. Negative 1/2, negative 3. Now, number 8, I'm going to do with substitution so we can see the other method in case you want to use it. For substitution, you're going to pick one of the equations and solve for one of the variables. I'm going to do the second equation and solve for r. Okay, so I'm going to minus the 4q from both sides because I'm trying to get r by itself. And then I'm going to divide by the 2. R equals 28 minus 2q. And then I'm going to take the value that r is equal to, and I'm going to substitute it into the first equation. So I'm going to write the first equation, and where I see r, I'm going to substitute that value in. So I have 8q minus 15, and then again, I'm going to substitute the value in. 28 minus 2q goes in place of the r, and then that is equal to negative 40. You always substitute into the other equation, otherwise you'll go around a circle. 8q, if I distribute this, minus 420 plus 30q equals negative 40. And then I'm going to combine my like terms. 38q minus 420 equals negative 40. Add the 420. 38q equals 380. And then I'm divide, and q is 10. So there's a q value, and I'm going to take that and I'm going to substitute it back in to this equation I came up with up here for r. R equals 28 minus 2 times whatever q is, which we got 10. So r is 8. The final answer, you always list alphabetical, so q comes first, so it's 10 and then 8. And then the last equation I'm going to do is get rid of fractions, because we all know how much we don't like fractions. So we're going to get rid of the fractions by multiplying the entire bottom equation by 9. The reason why I'm picking 9 is because that's the biggest denominator. And so if I do that, 1/3 times 9 is 3x. Negative 4 over 9 times 9 would just give me negative 4. And 4/3 times 9, if I do 4 times 9 is 36, divide by 3, I get 12. So that's my new equation. My original equation here in red, my second equation is the one in purple. And then you might say, whoa, what just happened? They're exactly the same. So these two equations are actually exactly the same equation, which means no matter what number I put in, I'm going to get an answer that works. So this is going to be all real solutions on the line. So if I graph this line, any number on the line will be a solution to the graph. Okay, so all values on the line, all real solutions on the line, whatever you want to think about. If I were to graph this line, right? It would be, every answer would be the same because they're the same line. Now you're going to do the you do part for the rest of the problems.